Today's powerful FPGAs enable developers to reduce the size, weight, and power of previously bulky systems, which are then embedded in vehicles, satellites, and used in other innovative applications. In this video, we will hear from DornerWorks embedded software engineer Brian Kachala and senior FPGA engineer Juan Morales, who will talk about using the high-level synthesis tool to optimize and accelerate algorithms on FPGAs like the RFSoC and Versal. By allowing developers to work at a higher level of abstraction and automatically generating FPGA-optimized RTL code, the HLS tool can significantly speed up the development process and help achieve faster and more efficient implementations. First, an introduction from DornerWorks innovation leader Greg Wilds. Greg, how was the RFSoC used as a foundation for this project?
Great question, Matthew. DornerWorks is a premier partner with AMD Xilinx, and we were a launch partner when the RFSoC came out to the market. And this is now on the order of 5-6 years ago. We've worked with a wide variety of customers enabling medical imaging, aerial radar, ground radar types of systems, as well as spectrum analysis systems that are leveraging that powerful SoC. Right now, the project that we're featuring within this blog is actually RF sensing and spectrum analysis focus. And so we're using both the AMD Xilinx RFSoC as well as the latest chip, Versal, to do the data and signal processing. So right now, our end customer is funding DornerWorks to be an integration partner with a number of both universities as well as OEMs that make RF systems. So we work with the universities and the researchers at these large corporations, taking their algorithmic functionality from MATLAB, C, and Python, and integrating that onto the AMD Xilinx RFSoC and Versal platforms to both accelerate the functionality, the algorithmic performance, as well as significantly reduce the size, weight, and power of that embedded platform. That enables our end customers to take that algorithmic functionality for RF signal characterization and make it very small. And so in a sensor pod, they may be able to have multiple sensors now that have that real-time processing already integrated instead of a much larger system. We're excited to be working on this project.
What solution did DornerWorks engineers implement?
There's different algorithms out there already, like software implementations through different libraries. Those include two we looked at were the scikit implementation in Python and the MLPAC implementation in C++. So we kind of started off with those somewhat as a base, and went through that. I used the HLS tool to kind of translate those algorithms into code that's able to be synthesized or used by the tool. So you have to do some translation efforts because there's some constructs that aren't available in C++ or C that aren't available in Vias HLS that the tool understands how to use it. So you have to do some translation effort there. But once you're able to do that, then the tool goes through and will synthesize all of that, the C++ into RTL. And then you can use that on an FPGA and run it that way. So I did most of the translation efforts. And then on top of that, the algorithm design doing the like there's optimization tools that you can go through with the tool, and there's like different directives that you can say on how you want the tool to lay out the algorithm and the FPGA. So I went through doing a bunch of iterations of that as well to improve the algorithm.
So I think what I'd helped on was taking over from Alex, who was our intern at the time. He had started the Vivado project, and they were having some issues meeting timing, so I just changed a few things there to improve timing. And got it to run at 150 megahertz with just default settings. So I think that was the main thing. And then just I brought everything, all the scripts together, and then added make file scripts for building the Vivado project and also the Vitus bare metal app. We do also have a Pedal Linux test app, which does essentially the same thing as the bare metal app, was just easier to debug with the bare metal app.
How does the high-level synthesis tool benefit developers?
So the tool will kind of give you guidance on different ways that your current algorithm state can be improved. So that was super helpful, saying, hey, like this could be run at the same time as this, or you might, like based on how you have it, there's kind of a bottleneck or restriction here. So if you lay it out this way, it should be able to improve your algorithm. So the tool definitely helped in that sense. And then also on top of it, I'm not very fluent in RTL languages at all, so I would not be able to get it. It would take a lot more effort in learning on my part for me to actually just get it working on an FPGA. I thought it was just really interesting seeing the initial implementation, which was, I don't know, like going through the tool, it estimates the runtime and the resource utilization and whatnot of it. And my initial like kickoff iteration of it was about 10 times slower than software than what that was running. But after going through multiple iterations of improvements, I got it anywhere between 20 to 50 times quicker than what the software implementation could be based on a whole bunch of different input parameter factors. But yeah, it's just really cool seeing the improvement that you can get with it.
Yeah, it was pretty interesting to see like the code that you have to write for the HLS style to infer the desired hardware, and then the use of pragmas to help with the right result that you want.
Yeah, I mean it's very very fair. It is C++ code, but that is like how I structured the algorithm is not even close to how I initially had it at the beginning. Like it doesn't you really couldn't really tell the steps to go from A to B. Like it's completely different getting it to kind of implement hardware how you want it to. So you have to kind of structure your C++ code in a similar fashion to how you would kind of expect the hardware to be. It can do a lot of like it can imply kind of what you want sometimes, but other times it cannot, and you have to kind of structure it that way.